New battery. Okay, 6/7/2022. Today is my brother's 60th birthday today. Old man. All right, angle of elevation. So it is always from the horizon. Elevated up. So from the horizon. I mean, the horizon is like, the flat part. If you're standing on the ground, you looked off on the horizon. It's from the horizon up. That's my angle of elevation. Pretty easy. We've talked about the angle of elevation before. When we did our hot air balloons, we measured the angle of elevation. When we did our rockets, we measured the angle of elevation. All of those projects were using right triangle triangle. You guys just hadn't learned it yet. But, it's okay. I'm glad we did the projects. But all of those use right triangle triangle, okay? So we've done this problem tons of times. Let's do it again. A 6-foot man cites the angle of elevation at the top of a building to be 64 degrees. If he is 100 feet away, how tall is the building? Okay, now, don't let the words freak you out. We're doing right triangle triangle. Let's just draw a right triangle, okay? So draw a picture is very helpful for you, okay? So I've got a building, right? Here's my building. I've got a 6-foot man. He's going to cite the top of a building. And we've talked about how that 6-foot man elevates the right triangle. So the right triangle is actually 6 feet above. So put in my 64 degrees as the angle of elevation. Now if he's 100 feet away, that's my adjacent side, right? That's 100, which is also 100 here, okay? Hopefully got a right angle. How tall is the building? Well, we can do this. We've done this lots of times. It's not that difficult. We know that the building, let's just call it B for building. You okay with that? And Grace, help me out again because you're so good at this. What's the first thing we do? There you go. Go to the angle. You guys agree? So start with the angle. Okay, and then what do we do after we go to the angle?
Plug in the equation, so
Right? Label your sides so we can figure out which equation. Scott, you're ahead of me. I like that. But we have to name the sides. We don't care about the hypotenuse. Hypotenuse is irrelevant in this example. We don't care about the hypotenuse. It's irrelevant. But we do want to find the opposite, which is the height of the building, and we want to use the adjacent. So, okay, again, opposite adjacent. Scott, you're right. We look up on the board for the one that works.
Tangent.
Very good, Grace. You're awesome. So you do tangent of theta equals my opposite over my adjacent, right? So theta represents my angle. So I'm going to put 64 degrees here. My opposite is my building. I'll put that there. And my adjacent is my 100. I'll put that there. Okay, so tangent of theta, which is my angle, 64 degrees, is equal to my opposite side, which is B, over my adjacent side, which is 100. Okay? How am I doing? Thumbs up. And this is about the 5th day we've been doing this, so we should be getting good at this. Okay? So then, to solve for B, what am I going to do? What am I going to do? Tava, tell me, what am I going to do?
Plug it into the calculator.
Yep, let's multiply 100 first, but yeah, we will. Okay, 100. Okay, and then I grid, huh?
205.
205, you're way ahead of me. I like that. Awesome. Okay, so clear 100 tangent of 64. And you guys, we've got to pretty soon start being careful about our mode because my algebra 2 kids are going to start doing radians, okay? So we'll have to start checking our mode pretty soon. 205, and then we got one last thing we're going to do. Take the 205, we're going to add in this 6 feet, so 211 feet, okay? Add in the 6 feet because that's the height of the 6-foot man. Okay, easy? You guys agree? You will have a question like this on your test. You will. And of course, that's not too bad. You guys can do that. You guys agree? Here's my answer. Okay, angle of depression. So again, from the horizon. And we just rotate down. Picture that. There's my angle of depression. Okay, another opportunity to draw an airplane. We'll see how bad this one is. So an airplane, 5,000 meters in the air, begins a descent to the airport at an angle of depression of 10 degrees. How far is the plane from the airport? Okay, so here's my airplane. Let's see if I can do a better job. Oh, that was pretty good. So from the horizon.
Oh, that's a good airplane.
That was better, huh? Almost looks like a bird though, doesn't it?
That looks like a bird.
Well, that's okay. So, okay, here's my right triangle. $5,000 meters above the ground, right? I don't need this other triangle. I don't need it, but sometimes, you know, it's helpful to look at it. The 10 degrees is here. It's obviously not there, and a lot of kids want to put it there, but that is not the angle of depression. The airplane's flying down at this angle, right? So how far is the airplane from the airport? So not the ground, but it's got to travel this distance, right? We could find the ground distance. I mean, somebody might say, well, Mr. Davis, really the way we measure is how far away is ground distance. I would take that, but really the airplane's got to fly that distance. So, okay, so Grace says the first thing we have to do is, Grace, what's the first thing we have to do? Go to the angle, right? Let's label our sides. That's my opposite, my adjacent, and my hypotenuse, right? I know the opposite is 5,000. Because 5,000 here, 5,000 there. Because airplane is 5,000 above the ground. And you can use either triangle, but I'm just going to use this one. All right. So I know the opposite. I want to find the hypotenuse. I don't care about the adjacent. It's irrelevant unless I want to find the ground distance. Okay. It's irrelevant, so I don't care about the adjacent. So again, I look up at the board in blue. And I'm looking for opposite hypotenuse. Opposite hypotenuse. Yeah, we do sine of theta equals my opposite over my hypotenuse. Or sine of 10 degrees, because that's my angle, is equal to my opposite, which is my 5,000. Over my hypotenuse, which is x. Okay, how am I doing? Okay? So if I have to multiply by x up there, but then I have to divide by sine of 10. Remember that? So it's just easier to switch places. The variables on the bottom, just switch places with it, divide. Okay? So we'll do that. All right, so I'm going to rewrite this as really x is equal to my 5,000 divided by sine of 10. I'm just going to use my calculator. Oh, turn on 5,000 divided by sine of 10. And I get an answer about 28,000. This is in terms of meters, so it's got a 28,793.9 meters to go, okay? How are we doing? Thumbs up? Thumbs up, everybody? Okay, I see one thumb up. That's it. 2 thumbs up. No more? Okay, all right. It's early, huh? Okay, turn the page. Okay, find the area and perimeter of an isosceles triangle that has a vertex angle of 40 degrees and a base of 12. So let me draw a picture, okay? That always helps. Okay, so I'm going to draw like that. And Mr. Bard.
Am I interrupting you?
No, you're never interrupting me, okay? I mean, if they get stuck, they can always reference Mr. Bard, right?
That's right.
We won't need, they won't get stuck, okay? Area and perimeter. Okay, so let's draw a picture, always, right? We've got a vertex angle 40 degrees, right? And a base of 12. Okay, but here's a problem. We do not have a right triangle. It's a right triangle trig. That's easy to fix, isn't it? Let's find a right triangle. Cut it right down the middle, huh? Let's just cut it right down the middle. Let's do that. Let's take and cut it right down the middle, okay?
So
Okay.
why didn't you make it an
With the 40 here,
Oh, that's right.
we can get these other angles. Should we get these other angles real quickly? You know what, Scott? I'm gonna back up and I'm gonna do something else, okay? Real quickly. I'm gonna do this 180 minus 40 is what? 140. I gotta divide that into the 2. Yep, divide by 2. 70 degrees, 70 degrees, okay? Thank you. That actually is gonna help me, isn't it? So now if I divide this straight down the middle, Scott, I'm gonna have,
It's not like 40, 60, 80.
no,
Oh,
right? Since isosceles, I do know these two sides are equal, right? I do know those two sides are equal, and I know the base angles are equal too. So what do I know about isosceles triangles? Two sides equal, two base angles equal. But what I did is I just created a right triangle. I have to have a right triangle because without a right triangle, I can't use my right triangle trig. So let's just look at one of the two, okay? All right. So let's find all the sides. So let's find the value of x. Okay. Well, let's see real quickly. If I do this little thing here. Okay, I don't know if you need to do this. I don't know if this helps, but that's 6. That's 20 degrees, and that's x. Okay, do you agree with that? Do you agree with that? And I made that line too long, but I'll get rid of that. Okay, do you agree with what I did? I just redrew a right triangle. Okay, so let's find the value of x. All right, so step 1, always start at the angle. All right, I can do that. Boom, 20, right? Step 2, let's label my sides. That's my opposite side, and that's my hypotenuse. Then let's look at the board and figure out which trig ratio we need to use. I've got opposite hypotenuse. Okay, so what am I going to have to use? Sine, yeah. So I'm going to go sine of theta, or sine of 20 degrees, equals my opposite, which is 6, over hypotenuse, which is x. All right. Again, when x is on the bottom, I'd multiply it up, and then I'd have to divide by the 20, so I'm just going to go x is equal to 6 divided by the sine of 20 degrees. And I'm just going to use my calculator. I'm going to go 6 divided by
46.
sine of 20. You're ahead of me, Scott. I like that. I got 17.5.
Oh, wait, sorry.
Did you divide or multiply?
No, I asked the plus.
Ah, gotcha. Okay, you might. Okay, so this side, I'm gonna put that in there, is 17.5. Actually, I'll go back to my main figure. Okay, 17.5, 17.5. Okay, I can find perimeter. Perimeter's gonna be pretty easy now. Okay, that's no problem at all. Perimeter is gonna be the sides. It's gonna be a 17.5 plus another 17.5 plus 12. Everybody agree with that? I'm just adding them around. That's perimeter. 17.5 plus 17.5 plus 12. Okay, so I'm going to go then 17.5 plus 17.5 plus 12. I get 47. Scott, is that what you were already saying?
I didn't do the half.
Oh, gotcha. So my perimeter is 47. Oh, let's just say centimeters, right? Good. Now area. Well, it's a triangle. So area of a triangle is going to be 1/2 its base times its height. Okay. I know the base, but I don't know the height. Oh, well, okay, I got to do some more right triangle trig. I can do that. So let's find the height. Let's find the height. All right. Well, the height is my adjacent side. So we could do it one of two ways. Either we could do Pythagorean's theorem. A squared plus b squared equals c squared. Or cosine. And I think cosine is easier. That's my opinion. Pythagorean's theorem would work. H squared plus 6 squared equals 17.5 squared. I like cosine. I think it's faster. So for the height, I'm going to go my cosine of 20, because adjacent and hypotenuse is equal to my height over my 17.5, right? And then, solve by going 17.5 times 17.5. How am I doing, okay? That'll cancel. And use our calculator. 17.5 cosine of 20. I get an answer of about 16.4 maybe, okay? So the height's 16.4. This is a hard problem, huh? Lots of steps. So finally, let's get the area of this thing. Okay, the area is 1/2 the base. Now we're looking at this triangle here. The base, which is 12, times the height, which is 16.4, 1/2 times 12 times 16. What's the what?
What's that in your calculator?
Oh, thank you, Scott. No, I made a major, that's natural log. I would have messed up. Scott, I had the wrong answer. Thank you. My fat fingers. Clumsy fingers. Okay, how about a 98.4 for the area? And it's centimeters, so it's got to be centimeters squared, okay? What do you think? If I had a problem like this on the test, could you do it?
Yeah.
Good. Okay. Now, example 4 is very similar to example 3. Very similar. Except for one thing. We need some angles. We need some angles. Well, it's equilateral. So the first thing I'm going to do is change the problem into 5 triangles. Okay? The first thing I'm going to do is change it into 5 equal triangles. They are equal. Well, how many degrees are in a circle? Good. So if I take 360 degrees and divide it by the 5, I'll get 72 degrees. You guys okay with that? So 72, 72, 72, 72 degrees, 72, okay? I mean, that makes sense. Everybody agree? Okay with that? Now, since this is right triangle trig, I need a right triangle, right? So I'm going to take, let's just look at this one triangle here. I'm just going to superimpose this triangle here. Let me take this triangle. I'm just going to draw it again down here to make it easy for myself. Okay, easier. I'm just going to draw it bigger, but I'll show you what I got. Okay, so I took this triangle, just going to make it bigger, okay, because I want to look at it. Okay, so here's so this triangle is right there, okay, there's my 10 and my 72, okay? All right, now, I need a right triangle, right? So what do you think we should do? Yeah, cut it right down in half, I agree. So I'm just going to take this thing, I'm just going to draw it right in half, okay? Oh, bad. That doesn't even look right, but it's going to work. Okay, now, I'm going to redraw this triangle one more time, but only half of it, right? So, all right, I'm going to go ahead and redraw this triangle, like right here, but only half of it, right? Because Gretchen, you're right. Let's cut it in half, okay? All right, so then 5, 36, and 90, okay? All right? Now, if I can find the area of this triangle, if I can get the area of this triangle, then I can get the area of the bigger triangle, and then I got 5 of them. I'll say it again. if I can get the area of this little, or the height, if I can get the height of this little triangle, then I can get the height of this one, and then I can find the area of this one. I got 5 of those. Giselle, I remembered your candy. I did. What do you got?
These are the awards. You just have to sign them.
Okay. I'll get it. Okay, thank you. So, now, let's do that. Let's get the height of this triangle, because the height of this triangle will be the height of this triangle, and then I can get the area of this triangle, and then I got 5 of them, right? Okay, so, all right, let's see. Go to the angle, opposite, adjacent, right? I don't care about the hypotenuse. Opposite hypotenuse is going to have to be opposite hypotenuse. Opposite hypotenuse got to be tangent. Okay, so I'm going to do tangent of theta, or tangent of 36 degrees, is equal to my opposite, which is my 5, over my adjacent, which is my h, okay? I'm going to multiply by h, but divide by tangent of 36. So the height comes up, and the 5 over tangent of 36 goes there, okay? All right, let's use my calculator, okay? All right, hold on, clear. 5 divided by tangent 36, about 6.88. Okay, now I'm going to be able to do this. Okay, I did use my trig, because I can go back to this triangle. I know this height is 6.88. I can find the area of this triangle, because it's 1/2, right? I find the area of this triangle, because it's 1/2 base, which is 10, times its height, which I now know is 6.88. I'm just going to use my calculator, okay? 0.5 times 10 times 6.88, 34.4. So that's the area of one triangle equals area of a triangle. But to get the pentagon, I'm almost done. There's 5 of those, right? So I'm just going to take, the area is going to be 5 times this, 5 times my 34.4, and I get 172, whoops, 172 centimeters squared. That's my answer. I got it. Okay, what do you think? A lot of applications, right? So, let me stop the recording. Stop. Stop.